share the presentation here.
Okay, and it has started recording.
Okay, so can you see the presentation?
Yep.
Good. And we're in presentation mode. Okay, well, let's go ahead and start. So this presentation is about the University of Maryland graduate programs in mechanical engineering and other related areas. So this is a picture of the University of Maryland on the left. We are the flagship campus of the University System of Maryland, which includes 14 different campuses. It's one of many land-grant universities that are in the United States. The engineering college at the University of Maryland was established over 125 years ago now, started in 1856. And mechanical engineering was in fact the first engineering department at the University of Maryland. So you can see here, there's our campus map. Engineering is about 15–20% of the campus. It is composed of engineering buildings. There's even some engineering buildings that are not actually in the central campus area, shown in that box. I included a picture here of the newest building in engineering. It's called the Idea Factory. You see there's even a crane next to it there. This is expected to open the first of the year, 2022, and it houses programs in rotorcraft and also robotics, as well as our student startup shell, which is an entrepreneurial space for both graduate and undergraduate students. So we are inside the Washington Beltway. Okay, we are 8 miles as the crow flies from the U.S. Capitol. We're on the Washington Metro subway line. And I'll pop up a picture of that in a moment so you can see where we're at. And you can actually see the Washington Monument from the top of the football stadium here. So we're that close to Washington, D.C. You can walk or take a bus to the Metro line. You see a picture of it there in the bottom right, and you can literally go anywhere in the Washington, D.C. area. And it takes like maybe 30 minutes or less, depending on the time of the day, to get down to the mall and the Capitol and all of that. You see in the upper right-hand corner is where the University of Maryland is at. We're on the green line today. We will be on the purple line. They are presently constructing the purple line, and there'll be 4 stops on campus or next to campus. You see them outlined above. The purple line will be completed, best guess, in a few years, hopefully. So University of Maryland Clark School of Engineering, we have over 4,000 undergraduates, over 2,000 graduate students. There are over 200 tenure track faculty, 17 National Academy of Engineering members, and you can see what our research expenditures look like there. What we're here today to talk about is the programs that are in the mechanical engineering realm, okay, which is mechanical engineering, also reliability engineering, and fire protection engineering. So all of these are under the banner of mechanical engineering here at the University of Maryland. So this is us, myself presenting, Peter Sanborn, upper left-hand corner there. Also, Jeffrey Herman below me is the head of the educational programs in the reliability engineering portion of mechanical engineering. And I also have Megan on lower left and Carrie in the center there, who are the administrators of the graduate studies program in the mechanical engineering department. And they are the people who pretty much know everything about how the system works. So if you're thinking of applying to the University of Maryland, these are the people to absolutely reach out to. So we have a whole set of stakeholders here that we work with. Obviously the graduate students, possibly yourself, the faculty, MAGE is a professional master's program, which we'll talk about a bit later. And of course, we have the administration at the University of Maryland, potential employers, and our peer institutions, the Big 10 Plus. These are all of the folks that we listen to and that come to us for advice and research and programs. So this program is ranked in the top 10% of the ME graduate programs by the US News and World Report. We are number 17 out of 182, and in fact, 9th among public universities. This is our fall 2021 graduate student population in mechanical engineering, specifically ENME and ENRE are mechanical and reliability engineering. MAGE is our professional master's program. They give a master's of engineering degree. ENME and ENRE gives PhDs and Master of Science degrees. So we're 295 total graduate students, and you can see the breakdown there between full-time and part-time students in all of our programs. So our 2020 degrees granted were 28 PhDs, 27 Master of Science, and 38 Masters of Engineering. So this is a snapshot of the support for the students. You can see there's a mix of students that are just teaching assistants, GTAs, just research assistants, and students that have a combination of both research assistantships and teaching assistantships. And then there's fellowships and scholarships on top of that. There are lots of students that have some combination of those things. So you can't simply add all those together and find all of our students. Pretty much at the University of Maryland, if they're not funded by one of these mechanisms, then most likely the student, I think almost 100% of the students are either funded by these or funded by their employers. Okay, given our proximity to the nation's capital, the Department of Defense, other government agencies, and many corporate entities, almost all of our students, well, all of our students are basically either funded by their employer to be here or funded by teaching assistantships, research assistantships, or fellowships. So this is a breakdown of our programs. Mechanical engineering has really 3 divisions plus fire protection engineering. Okay, so you see there are 16 faculty in the design and system reliability division. That's where I live. There's also mechanics, materials and manufacturing, and thermal fluids and engineering sciences. Okay, you see sort of the faculty breakdown there, plus the fire protection engineering program. We are 47 tenured and tenure track faculty, 13 research faculty plus 35 teaching faculty. There are 10 National Academy of Engineering members that are within the mechanical engineering area. Some of those are emeritus. And we have 9 named and chaired professorships within the department. And you can see the other breakdowns of other categories of faculty down below that. So our research centers are many. Okay, so there are more research centers than this, but these are the major ones. And to just give you, and you can look up any of them as you like, they're in different areas, but just to give you an idea, CALS is 100+ faculty, staff, and students, all focused in the electronic systems reliability space. So the Maryland Energy Innovation Institute, I just picked out some highlights here. These folks are the largest ARPA-E contractors in the United States at this point in time. So, and these centers here at the bottom of the page, these are all centers that have faculty, staff, students that are distributed across many different departments within the College of Engineering and maybe outside of engineering. ISR is mainly electrical, and mechanical, although there are aerospace engineers in there as well. The Maryland Nano Center has membership from material science, chemical engineering, mechanical engineering, electrical engineering. The Robotics Center, of course, electrical and mechanical engineering and computer science. And the Maryland Transportation Institute is really centered in civil engineering, but has lots of membership from mechanical engineering as well. So across all of these, okay, you'll find that none of these are 100% mechanical engineering. Okay, so which is a good thing. All right, so we're spread across campus in many different sort of spaces. So just to give you an idea, there's University of Maryland there inside of the Washington, D.C. Beltway. All of these government research labs are within 50 miles of our campus. Okay, ARL's, the Army Research Labs, for instance, they're literally only 10 minutes away. Okay, NIST is in Gaithersburg, Maryland, which is a half an hour away. All right, so, and you can see lots of others there, okay? The National Security Agency is at Fort Meade, about 30 minutes away, okay? NavAir is at Pax River Naval Air Station, okay, which is about an hour, a little over an hour away, okay? So all of these things are close by, okay? And we work with all of these entities. And there are lots of private companies that are close by too, corporate partners. The Lockheed Martin headquarters are in Bethesda, Maryland, about 20 minutes away. Okay, Northrop Grumman is at BWI Airport. Okay, about 30 minutes away. Okay, Amazon is building, of course, their East Coast headquarters in Crystal City, which is a half an hour away. Okay, Under Armour's in Baltimore. Okay, so all of these are our partners, and this is just a small sampling. There are hundreds and hundreds of corporate partners and corporate sponsors of research within mechanical engineering and the larger engineering school at the University of Maryland. So this is a breakdown of our funded projects, and these I think are the top 20 funders. And ARL is Army Research Labs, USDA, U.S. Department of Agriculture. You see lots of DOE, Department of Energy sponsorships, and others here. So this is sort of, and the pie chart gives you an idea of the breakdown of how our research is funded. So the next couple of slides here just give you some highlights from some of the different divisions within mechanical engineering. This is mechanics, materials, and manufacturing. Lots of biorobotics. Okay, so many different research projects and research efforts focused in the bio-inspired robot spaces. Okay, you also see lots of work in energetic materials, including battery work. Okay, so there's lots of battery development work. There's lots of battery reliability work here at the University of Maryland. And lots of microfluidics. Okay, so this is lab on a chip sort of stuff. Also, there's lots of micro MEMS and 3D printing development for things like electronics, for building RF structures, for sustainment of parts close to the point of need for various military and aircraft applications. The thermal, fluid, and energy science space. I think this plays as a video. Let's hope it does. Here we go. Hopefully you can see it moving there. We have wave tanks for studying wave experiments, tidal waves, and things like that. You see down in the lower right-hand corner here, carbon dioxide sequestration. We also do lots of work in how aerosols spread inside of controlled spaces. That would be applicable to COVID spreading. And propulsion and hypersonic flight. Okay, so we work very closely with our aerospace engineering department here, and work a lot on ramjet technology and other things. This is the division that I'm part of. There's a lot of work in the microelectronics and reliability spaces. This is microelectronics that goes into things as simple as your phone, but also into avionics on aircraft, things like that. So we're very interested in the reliability and sustainment of these sorts of electronics applications. We do a lot of work with supply chain risk. Okay, so we do risk and compromise. So here's a picture, for instance, upper right-hand corner of counterfeit electronic parts. So we do a lot of work in detection and network modeling for counterfeit disruption and blockchain for supply chain. We also do a lot of work on artificial intelligence-based discovery and invention in this DSR space as well. This is sort of the design part of it. And even use a lot of machine learning and AI techniques for doing things like forecasting of part obsolescence and other sorts of applications. Here's an example of reliability engineering spaces. You see the upper left is sort of control room type design for nuclear power plants and other kinds of facilities. Lots of energy security. I'm part of a program that just got funded by the DOE to do waste to energy reclamation and understand the costs of doing that and calculating levelized cost of energies and things like that for waste to energy. We also do a lot of prognostics and health management for systems, having systems actually predict remaining useful life and then optimizing the maintenance actions to take based on that remaining useful life. And this is applied to helicopters and aircraft, to wind turbines and wind farms, to batteries and other kinds of systems that are safety, mission, and infrastructure critical sorts of items. We have a fire protection engineering program. There are not many of these programs around. There's only a few in the United States. And some of the videos you see here are studying things like wavefront formation in 0G and things like that. Okay, Megan, I'll turn it over to you to talk a little bit about what the logistics are.
Sure. So here's kind of just a simple breakdown of our program. So this is obviously after you've been admitted. During the first semester, we ask all of our students to submit what we call our plan of study. You create this or put this together with your faculty advisor. And it's basically just a plan of all of the courses you're going to take during your program here and kind of a proposal of your plan. And then if you're an MS student, a master's student, you're also going to include your any transfer credit forms. During the second semester, for any of our PhD students who already have a master's degree, you're going to take the qualifying exam. So that's one of the major milestones of our PhD program. And it's basically an oral exam for our faculty kind of make sure that you understand and are up to date on all of your coursework in order to move forward in your PhD program. And then in the third and fourth semester, if you're a master's student, that's when you submit some additional paperwork to make sure that kind of everything is set with your coursework. And if you are a PhD student, you do the second milestone of your program, which is our PhD proposal. And essentially you're presenting a proposal for your dissertation and what you'll be doing your research on. And then once you're finished with that, you advance to candidacy to be a PhD candidate. And then before your last semester, you either submit your nomination of thesis or dissertation committee forms. And then in the final semester, you're finishing up your paperwork and then either defending your thesis or dissertation. And then what you really probably want to know today as far as the application process. So that goes through our graduate school. They send us your complete application, which includes your official transcripts, and either a TOEFL or IELTS score if you're an international student, 3 letters of recommendation, a statement of purpose, CV, or resume. We're currently waiving the GRE for fall 22. And that's kind of been a discussion of whether or not that will be a thing in the future, but for right now, we're waiving it. And then we are also currently offering a fee waiver for our first 200 applicants, PhD applicants for fall. So we're still under that quota. So there's no fee, no code or special instructions or anything to receive that fee waiver. You simply have to apply. And then our application deadlines for fall, December 3rd is our priority deadline. So that's when we recommend you get everything in. You get all of that information in your application, and then you don't have to worry about that if you're finishing finals and things like that. And then for international students, the final deadline to apply is March 11th and May 13th for any domestic students who do not wish to be considered for funding. And then we always recommend to all of our applicants that you contact any of the faculty that you're interested in working with and who you share research interests with. You can just reach out to them through their email. And you can find that through our faculty directory on our website.
And we'll go ahead and reiterate that lots of our graduates go to work in the region, okay, and have internships even possibly during their studies to work in the region as well. And here's a quick snapshot of where some of our graduates go to work. This is by no means complete, but we provide lots of graduates to NASA. The NASA Goddard Space Flight Center is only 20 minutes away, and other governmental employees. We, of course, provide lots of graduates to go be academicians like ourselves at various different schools, lots of private employers. I'm not sure exactly what the largest employer is right at the moment, but Northrop Grumman, Lockheed Martin take a lot of our engineering graduates, but we provide a lot to Apple, Microsoft, Boeing, and others regularly come and take a lot of our students, hire a lot of our students, and also international employers, as you see. So, and Andy, I can turn it over here to you to say a few words about Mega.
Okay, thank you. And can you hear me?
Yes.
Okay, hello everyone. My name is Andy. I'm the current Mega president, and as well as a PhD candidate in mechanical engineering. And let me introduce what is Mega. So Mega is the Mechanical and Reliability Engineering Graduate Student Association, where we basically represent masters and PhD students in both mechanical and reliability engineering. And our goals are to support students during all the stage of their student career and to enhance their graduate school experiences, and also advocate on the behavior of the graduate students to the department. And typically on each semester, we hold a series of events. For example, the graduate mentoring program, which is we connect all the current students, we connect some of the current students to the incoming students to help them to have a better idea about what's the graduate life's gonna be at the UMD. And also we hold a fall picnic on each September, except for the except for the last and this semester due to the COVID situations. But on the normal fall semesters, we always reserve a park which is near to the campus, and we invite all the graduate students and faculties to join us do the barbecue and play volleyballs. It's actually a really good opportunities for students to build up their social networks and also learn others' research, so they know what's going on in other research groups. And we also have the codifying exam workshops as a partial requirement for all the PhD students in both mechanical and reliability engineering department. They are required to take the codifier within the 2 years after they got involved. So this workshop can provide tips from the students who have already passed the QE in previous semesters, so that the new student can have a big picture on what's going to happen, what's going on here. And also we have the coffee and donuts Friday. On every Friday we have the coffee hours. We provide free coffee, donuts, and bagels in the graduate students lunch room. And so students are welcome to join and to have a talk on their graduate life. And we also have the TA awards, which we're gonna provide like Amazon gift card for the best top candidates. And also we have the town hall meetings where we join for students, and we can provide questions, collect questions from students and even their concerns, and talk this to departments, and then keep the student updated. The last thing I want to mention about is the elections. So officers at Mega, is up to 2 years. So all the candidates will be nominated by the end of spring semesters. So currently we have the officers are me and James, but we're for sure going to make Mega stronger, just like what we were before the COVID. So I believe the next election is gonna happen sometimes in March or April next year. And several positions such as president, treasurer, and communication director, mentoring program director are gonna available. And we will send these notifications by email and by the WhatsApp group chat. So yeah, so if you have any questions or you want to learn more about Mega, you're welcome to send an email to our official email address, which I believe is listed here. And thank you so much. This is the introduction for Mega.
Thank you, Andy. We appreciate you being here.
Thanks.
So just to wrap up, this is us. Those are the URLs for the different programs you've heard about today. Please feel free to reach out to us if you have any questions. And the graduate office at the mechanical engineering department would be happy to help and happy to potentially link you to faculty that are in your interest areas, or answer your questions about how to apply to the program and the other logistics. So thank you very much for watching this presentation today. Megan, Carrie, anything to add? Okay. With that, I guess we'll stop the recording.